Now let's look into the another algorithm that we have uh, in wrapper type feature selection. So that's forward selection. So forward selection, also known as wrapper type feature selection, is a feature selection technique that builds a model by iteratively adding features based on their individual performance. So let's have a detailed explanation of forward selection. So let's begin with, as usual, a definition and explanation. Then we will move on to different aspects of forward selection. Forward selection is a wrapper type feature selection method that evaluates the performance of different feature subsets by training and testing a machine learning model. So it starts with an empty feature subset and incrementally adds one feature at a time based on their impact on the model's performance. The algorithm continues to add features until a certain stopping criterion is met. So now let's look into the applicability. So forward selection is applicable to both single sample and multi-sample data sets. It can be used with a variety of machine learning models and evaluation metrics. It is often used when the goal is to select the most informative features to improve model performance. So now let's look into the mathematical equation or formula. Does it have any one? Does it have a one or it doesn't? Let's look into that. So mathematical equation or formula to do that this algorithm uses. So there is no specific mathematical equation or formula for forward selection. Instead, it involves an iterative process of adding features based on their performance evaluation. So now let's look into how this algorithm works. Algorithm working process. So the general steps involved in the forward selection algorithm are as follows. And the first step, start with an empty feature subset. It always, this forward selection starts with an empty feature subset. Then initialize a performance matrix such as accuracy or mean speed, accuracy or mean squared error to measure the model's performance. The step 2 is to initialize a performance metric such as accuracy or mean squared error to measure the model's performance. Then step 3, to iterate through all available features not yet included in the subset. Once iterating through all available features are done, now we will move on to the step 4, which is add one feature at a time to the existing subset and train a machine learning model using the updated feature subset. So once this training is done, then important step is to evaluate the model's performance using a chosen evaluation metric such as cross validation or holdout validation. So then step 6, keep track of the performance metric for each feature added to the subset. Then select the feature that resulted in the best model performance and add it to the subset. Then repeat step 3 to 7. So repeat step 3 to steps 3 to 7 iteratively until a desired number of features or a stopping criterion is met. Example, no improvement in performance reaching a predefined number of iterations, whatever it may be. So we have to repeat the step 3 to step 7, which is nothing but iterating through all available features which were not included yet in the subset till select the feature that resulted in the best model performance from the respective subset and then add it to the subset. And till step 7, we have to iteratively run this algorithm until you get a desired number of features or a stopping criterion. And when we say stopping criterion, it's nothing but meeting the condition that no improvement in performance is it can be done, or maybe reaching a predefined number of iterations. And final one is to determine the optimal feature subset based on the best performing model. So that's what is the step 9, or the last step. That's it. It's time to determine the optimal feature subset based on the best performing model. So now let's look into the applications of it. So forward selection is widely used in various machine learning tasks, including classification, regression, and clustering. It helps identify the most relevant features that contribute significantly to the model's performance. Some applications of forward selection include, let's begin with disease diagnosis, identifying the most important biomarkers or symptoms for accurate disease diagnosis. Then image recognition, very important. Image recognition, selecting the relevant visual features for object recognition or image classification tasks. Then we have the text classification, choosing the most informative words or features for sentiment analysis or spam detection. Then we have the financial forecasting, so identifying the key economic indicators or financial variables for predicting stock prices or market trends. So these are the applications, these are the fields where we can apply the this forward selection algorithm for the feature selections, for the features selection. However, let's see some of the real life examples where we can apply directly to the particular tasks or particular activity. So let's begin with spam detection. So forward selection can be used to identify the most relevant features from email messages such as subject lines, sender information, and content to build an effective spam detection model. And we have the predictive model maintenance also. So predictive maintenance, again, it's a forward selection can so predictive maintenance, so forward selection can help identify the critical sensor readings or operational parameters that contribute to the failure prediction of machinery in industrial industrial settings. And we have two more. We got credit scoring. So in credit scoring, forward selection can be employed to select the most influential variables such as income, credit history, and debt to income ratio for building credit scoring model that predicts the likelihood of loan default. And the last one that we have here, of course, these examples are limitless and endless, but still we will take some of them. So disease diagnosis, as we have discussed earlier, in medical research, forward selection can be used to determine most informative biomarkers or generic features for diagnosing diseases like cancer, Alzheimer's, or diabetes. So this is what you know now forward selection, which is of a wrapper type feature selection algorithm. By iteratively adding features based on their performance, forward selection enables the selection of the most relevant and informative features for building accurate and efficient learning models machine learning models.